Hello everyone, Mrs. Heist here. Today we're going to talk about runoffs and then different types of surfaces in our watershed that impact the amount of runoff. So first, our definition of runoff, if you've forgotten. Runoff is the excess liquid that flows across the surface of the land and into nearby creeks, streams, or ponds. So runoff can come off of roofs, off of your lawn, off the street, end up in our local waterways. Around campus and around our city, you can see storm drains like this one pictured here. This one's out in the parking lot in front of the gym, and it's labeled that this is going to drain into a waterway. Now on our campus, some go to waterways, others go to a storm water runoff retention area, and we'll talk about that at the end. When it comes to the amount of runoff, so how much water passes through, it depends on two different surfaces and how much of an area is covered with them. The first are the permeable surfaces, also known as the porous or pervious surfaces. These allow water to percolate into the soil. As the water enters into the soil, pollutants can be filtered out. Now they're not leaving the environment. Those pollutants will stay in the soil as the water goes deeper down into the aquifer. And as the water goes down, it recharges the aquifer or refills the aquifer. Examples of these surfaces include grass, soils. You can think of areas with lots of trees where there's gravel. On our campus, sports fields would be considered a more permeable surface. And then there are the impermeable surfaces, also known as impervious or non-porous surfaces. These are going to be any solid surface that will not allow water to penetrate or to come through. So we've got places with lots of concrete like this parking lot. Wherever there's a building, roofing, there's a building here, rain does not go and soak into the ground underneath. So campus examples include parking lots, the band pad, the building itself, the tennis courts, would all be impermeable surfaces. So here's a picture of our campus from Google Maps. And we can see that we've got lots of building of impermeable surfaces. And then here's our permeable surfaces, a lot of our sports fields. So the impact this has on our watershed. As the amount of impervious cover increases, we're going to find that there's more runoff because the water can't soak in. It's going to run off across the surface now. Potentially more pollution, because usually where there's more impervious cover, there's also more pollution because there's more people around. Pollution can be as simple as litter. It can be chemicals, oil that's leaking from the cars. Could be even some of the pesticides or herbicides that are sprayed. Because we've got now more runoff, there's going to be less recharge. The water can't get into the aquifer, so the aquifer is not going to fill up. The third thing that happens as we get more impervious cover is that we can end up with more flooding. So now when it rains, instead of some of the water being able to soak into the ground and some move across the surface, if it's all primarily impervious, the water is not going to soak in. It's all going to flow across the surface, which in catastrophic events like hurricanes means more flooding, or during some really heavy rainstorms. One of the things that Houston and East Texas is doing as they rebuild from Harvey is they're adding in more green spaces and more areas to catch water and give it a place to soak into the ground instead of just flowing across the top and creating flooding. On our campus, we've got a couple of features that help collect runoff. These are called storm runoff retention systems. They are very important for catching excess runoff because, again, if I go back here, we've got a lot of campus that is impervious cover. And so these systems, we've got 2 up front along Kyle Seal and then 1 in the back towards the tennis courts. This is a picture of the one up front. What these retention areas do is some of our storm drains do not lead to Leon Creek. Some do, some don't. Here would be a storm drain right up here that leads into this retention area. This is an area that's going to catch excess runoff, so it helps reduce flooding too. But it provides a place for that water to sit and to soak into our aquifer. Tomorrow we'll talk more about aquifers, and we'll learn that our school is built on top of a zone called the recharge zone. And the recharge zone is very important when it comes to increasing the amount of water in our aquifer. And that's something we're very concerned about since the Edwards Aquifer is our primary drinking source. And so around our campus, and you might notice some of these in other places as well. There's some near the HEB over at 1604 Bandera. There's some in La Cantera that are there for catching the runoff and giving it a place to soak into the ground.